Hello YouTube. We have a little treat I got my hands on recently. A McIntosh MC2105. This came up for sale recently and I pretty much jumped on it because I don't ever really see McIntosh gear where I live. And I just figured I wanted to get my hands on a nice industry standard, well-regarded solid-state amp. So I got this, and let me tell you, I was very unfamiliar with it. I'm shocked at how much it weighs. These are actual transformers, output transformers for a transistor amp, which I didn't even know about. I guess it was a McIntosh thing. I don't know how common that is. So, as you all may know or realize, I'm much more versed with tube amps, particularly guitar amps. I don't really know much about hi-fi, and I know even less about transistor amps. But I figured buying this, there would be enough information online about McIntosh products that I could get all the service information and help that I may need to get it working. But here's the surprise. It works perfectly. There's absolutely nothing wrong with it. Okay? There was a little bit of noise on one of the gain. There's a left gain, right gain meter range, which just really sets the range of the meter in relation to the volume you have it set to. An on-off switch and a speaker on-off switch. The speaker on-off switch was horsing around, and just clicking it a bunch of times, it started working fine, and there was some noise on one of the gain knobs. And just turning it a bunch of times, it started to work perfectly. When I plug it in, everything lights up. The lights are a bit dim, but it sounds okay. There's no hum. There's no fault that I can find. So the purpose of this video is that I am going to document a layman's version of restoring this. I think it's from 1974. That puts it at 50 years old, and the electrolytic capacitors in any product this age have to go. Let's look at the top. The glass is in pretty great condition. There's some bubbling on the very edges here, right? I've learned that these glass panels tend to delaminate the paint from the back side. I haven't even cleaned it or anything, but you can see a few little bubbles, that line there, something over here, bubble there. There's some rust bubbling underneath the paint around the sides and on top of these sheet metal and transformer housings. But really, it's nothing that's going to bother the performance in any way. And I live in the tropics, and let me tell you, for a 50-year-old product, that little amount of rust, again, has this thing in damn fine shape, right? Because a lot of old electronics I come across are in way bad condition, okay? So I'm going to open the bottom, take a first look inside, then start picking away at these top panels to try and get access to all of the parts. And I also have to get this glass thing off, which I'm nervous about because I don't want to break it. But that would be, that has to come off for the purpose of changing the bulbs. There's some bulbs that illuminate this blue section here, and there are bulbs that illuminate, backlight the lettering. Let's have a look at that now in its original shape, because I guess stock type bulbs in there now. And you can see not much illumination. You see the needles jump to life there, and you can see some light coming on at the top of the meters and an illumination of these letters. But in person, it's quite dim. It may look bright on this camera, but in person it's quite dim. I like the blue, and I want to restore the blue, but I don't want high output, you know, into the room. Here we could see the meter board. So this has two electrolytics that need to be replaced. Okay, so we have these two bulbs, and these generate a bit of heat, but I don't see that heat getting to the glass panels here. There's some criticism that the other lights, which you can see in the distance there, that illuminate the panel, give off enough heat, and they're the cause of the bubbling that I showed earlier. But these here are simple bayonet type bulbs. So those feed into the edge of that plexiglass by refraction. Maybe refraction is the right word there. Remove these bulbs. You can see here that regardless of whether I was changing them for LEDs or not, these bulbs are quite ripe for replacement, right? Heavy duty sheet metal screws that have to be removed, and this will come right off. So having examined this, I have nothing more to do than replace the electrolytics. Since the thermistors look fine, they look fine, and the amp is working. We're changing this, the blue things, and this, and these two, because I've just read so much that these go bad. One thing I would like to do for curiosity is to measure on these transistors on the input board and compare them to the schematic, because this is the area where I was on the fence. I bought a kit that supplies replacements of these transistors, but I don't know that it needs it. Okay, am I better off swapping these? I don't know. But if I measure these and find voltages different to the schematic, I'll be much more inclined, very much inclined to replace them, right? So I'm going to do a verification on that before actually digging into the amp. I can also do some other measurements and comparisons to the schematic that just give me a baseline about how things are behaving before I actually dig into it. Okay, so I had a look at this schematic, which is on my phone, so I don't have it laid out for you, but measuring these 6 transistors on the input board, they're out of whack with each other. I am, besides the basic rail voltage coming in, they're all off. So I'm inclined to change them. I will swap them out for the ones that came in the kit and remeasure. And if those are closer to spec, then of course they're going to stay in. Another thing we can see looking in closely here, electrolytic is venting fluid there. See? So it's now started. That's started to vent. So that's been changed first. This whole thing comes apart pretty quickly. Once you take out the sheet metal and screws that are in certain intuitive spots, it all comes apart. So now we're looking down. We're looking at the top, but with the screen removed. That just came off. And these are the major output transistors on the heat sinks. And there's 2 of those per channel. And in between each pair of heat sinks is a driver board, which I must scrutinize a bit and change some of the parts on it, right? And then these large capacitors in between them, that's the same one I just showed you. It's starting to leak, and that's the main power supply capacitance, these 2 big units. Now of course everything's quite dusty because dust and a few cobwebs have come in from the top side, and of course physically cleaning this is part of the whole job. Okay, let's look at a few things. I've taken off the front glass faceplate and very carefully set it aside. Now here we can see pieces of plexiglass, and those are what refracting the bulb's light and bouncing it around to do the backlighting of the lettering. Here's a blue plastic over the meters, and it looks very good. This blue is very vivid. It's not faded. It's looking a bit green when those bulbs were lit, but now it looks fine. And here are bulbs that need to be changed to LEDs for the purpose of that backlighting. Well, here we go. 2 machine screws held this in place, and here is your refractor plate made of plexiglass. I think I'll clean this as best I can. Definitely don't want to scratch up anything, but there's a few little spots of grime that I can clean off. And here we will just twist out the bayonet bulbs and replace them with the LEDs. And while we're at it, I'm putting a little bit of deoxit. I'm not really a deoxit spray person. I love just putting the deoxit in concentrated form directly onto the spot. So on these little bulb sockets, I'm just putting a little drop of deoxit. When I go through the amp, I'm going to put this on more items than I spray. I'm not really a sprayer. It gets everywhere. Well, you see how strong the blue is here. I'm not inclined to change it. Right, so these are from the 70s, but very much like computer boards. These, I took out a little flathead screw here, and at that point this is loose enough to just shake back and forth and get this driver board out. Okay, very carefully. Now this set of contacts here is a perfect example of what I like to put this on, the concentrated deoxit, instead of just spraying all over the place. So we have maybe a little bit of cleaning to do. Some dust has to be taken off, but the main thing is really just these two electrolytics. I am not knowledgeable about this driver board update. Everyone mentions it online, but there are very little instructions, and no one sells a kit about this driver updates. I really do have to look further into this issue. So if any of you watchers have more information, please tell me. Okay, so I just spent a couple of minutes over here at the chassis. I have used a paintbrush, a toothbrush, and a little bit of cleaners. I can do nothing. I have no powers to restore pitted chrome, but at least I could get the standing dirt and dust off of it. So I got this on eBay, and it contains mostly electrolytic capacitors, a couple signal caps, which are these pinkish Weimer branded. There's a lot of these kits online, and I simply chose one that had an overall, what I thought were the best overall branding of the capacitors. These are those transistors that I called into question earlier. I think I'm going to go ahead and change those. But for now, I'm just going to fish through these and separate the correct values out for each circuit section. This must be the set to replace the large silver can, which is a whole other story we're going to get into within this video. Right, so having opened that bag labeled output, which I think is this set of boards, I'm now confused because there are more capacitors than I see on the board. There's 6 replacement capacitors and 4 on the boards. There are these 4 transistors. So RTFM, I will go through my instructions and see what the hell these are for. I don't even know. Anyway, don't let my confusion throw you off. It's just that I get a little excited to make these videos, and sometimes I'm in the middle of figuring out what's going on, right, while making the video. Okay, so let's address that mystery. These are instructions from a gentleman named Ben, who is one of the sellers on eBay. Can't remember his full name. Right, okay, so this is what it says. These 2 paragraphs deal with it. They say there are 2 output boards, one for each channel, we know that. They are backed by these 6. Do these one at a time. There are 2 different versions of these driver boards, and both versions will have 133, but one version has a 150 and the other has a 10. So that's why there's this 2 extra capacitors. Also too, let's read number 7 here. Most transistors get but each driver has 2 to replace if you want. These have different pinouts from the old transistors. Oh, so now I have to look that up now. Okay? Right, so over on the left is what we're doing, right? Taking out the old and putting in these new ones. Now we can look at this to see. Was this going bad? This doesn't look like it was going bad yet. Maybe any little brown crustiness is evidence of a leakage. So and this has it. You can see it here. So this capacitor is bad from that chalky light colored stuff coming out there, and this one looks good still, but we still change them anyway. Again, they're 50 years old. Most important thing, observe the polarity. This one, the positive is on the left side. This one, the positive is on the right side. We don't want to get that mixed up. Those can blow. And here, you see it's oriented the same way, with the kind of ridged part here as being the positive. Okay, so I put the transistors in, well, half of them, and you can see there is a difference in the orientation, right? The layout, pinout is different. This one has the middle up top, which is the base, and on here it's the basis, well, however you describe that, left or right. But it took me a minute to figure out how to bend those pins and lay it out properly. Okay, since I have these things out and in hand, I am testing all the resistors. Testing resistors on a board can be inaccurate because what you're testing here is not taking into consideration what other components it may be combined with in the circuit itself. And usually what you have to do to get an accurate reading is to desolder one end, lift it off, and check the resistor then. But that's such a headache. You're doing damage to the circuit board every time you heat it, and to undo half of the connections just to push them back in is a headache. So because we have two boards, all I've done simply, and being a stereo amp, I'm simply tested the resistors in circuit compared to the other one on the other board, right? So once any particular one matched the other one, I considered that to be fine. And having gone through all very much matched each other and seem to be within spec. The only few that were off, there's some transistor bias resistors, and those are 22 ohms. And those I know get replaced in the driver bulletin that I mentioned, even though I'm not actually doing it. I know those get replaced. So anyway, they go under scrutiny. And I measured them and I got them all between 24 to 27 ohms instead of 22, right? Even out of the circuit, right? So I've decided to replace those. I have these on hand, which are very accurate at 22 exact. And I'm going to replace those. So those are the only resistors I ended up replacing. All the others that I observed were very much damn accurate and very well matched. There were some that were, one or two that were off by almost 10%, but that is within tolerance, right? Most of them are damn well matched. Right, so I soldered up these, finished working on these, and I did a little research overnight on what that driver board mod is. And what it was, they had, as I said, they had these boards shared among several models, 2105, 2100 and 2300. The 2300 needed a transistor update here for reliability, and the extra little parts were these capacitors were changed to half their value. These were changed to a slightly lower value to accommodate that change in transistors, and then the heat sinks were changed as well. So again, it's not a must, but I just wanted to clarify for myself what that mod really is, right? I'm going to move over to the amp now. I'm going to change these two capacitors now. All they need are screws loosen, and they pop right out. They don't have any sort of secondary fastening. These very screws on top, which are the connections, negative and positive, these are all that hold it in place. Okay, so you're keeping your eye on this section here. The amp is unplugged, all of its voltage has been discharged. Actually, I'm going to double check that now. I will check the voltage between these metal ledges here, and it says 0.4 millivolts, so that's safely discharged. If I put my hand there while the amp was on and plugged in, I would get 35 volts on my fingers. I do not want. Now, I work on tube amps a lot, and these same major capacitors would have a voltage pushing 500. So I'm accustomed to being very careful with those. Now, these have quite a bit of mounting hardware, some washers, other little grounding lugs. So I'm trying to get those screws loose without loosening all the stuff on this side, right? Okay, so this just popped right out. And you can see again, but this has started to leak out. This one now is being returned to the same position. These are the same thing, electronically equivalent parts, really. This is a General Electric all original unit. This is 39,000 microfarad, rated at 40 volts. This is 47,000 microfarad, rated at 80 volts. So this had a pretty small margin of error as far as voltage goes. But hey, it's been there for 50 years and it's done a wonderful job. So you've been retired with full honors, right? This also has a vent here. So they actually line up the same way, ready to put back in both of these. One is in already, and I tightened these screws and made sure not to dislodge any of the little lugs that was held in place by that very same mount. The main thing is to by eyesight line up the vent through the hole. Right, that's it for the big capacitors. Okay, having put these capacitors, and I'm poking around. I've been measuring these little resistors, these white cement resistors here. They all seem to be correct. None are blown. They look okay. And being done with these boards, I can now put these back home. And so now I'll do what I mentioned before. Put a little bit of deoxit on this set of contacts here. Just a bit will do. Smear that on. And then these each get pushed back. They're sort of left and right, so we've got to figure out which one goes where. This goes here. Okay, so main area of focus along with the driver boards is this input board. We have a bunch of capacitors to replace here. 8 capacitors, the 6 blue ones and those 2 yellow ones. However, again, when I earlier fired up the amp and did testing of these voltages, I was getting odd readings among them, unmatched readings. So I'm inclined to change these. Also, I've got to go through and check the resistors. Now, as I've mentioned before on the driver boards, I'm not disconnecting each resistor to check it. I'm just going from one channel to the next to make sure that they're evenly matched. If they're not matched, then I have a clue that one is out of whack. But once they match, I'm leaving it right there. Okay, so 2 5/16 nuts get loosened and this whole board comes up. So I'm going to go through this. I'm going to go and pull out my vacuum solder sucker and do a big unsoldering session of all the components at the same time. Doing these one by one is going to be a headache, right? In reading up on the instructions for the transistor replacement, again, the new ones are a different pinout from the originals, and I have to say that I'm going to give the kit a bit of a thumbs down on not clarifying with diagrams. I mean, it would have been so easy to include a diagram that would have accounted for the different pinout layout. I have to go and research the pinouts of these and twist my brain around to put them in the right order. I find it quite confusing, as simple as it is. I find it worrying. Okay, I figured out the differences in transistor orientation, and I've gone through and replaced all 6. These outer 4 are the same, and these inner 2 are different, but they have the same pinouts. I've done that. I have some little capacitors to reattach to them, and then I'm going to move on to the larger electrolytic capacitors. Okay, so I've just gone in here and marked little red crosses where the positive side of each of those capacitors goes, and I've just realized something, that this I don't think is original. Even though the solder joints looked original, did McIntosh ever use Nishikon capacitors? And the other question is that these in the middle, these two sets here, you can see the blank holes here, are supposed to be non-polarized or bipolar electrolytic capacitors, and that these are what were there, and these are polarized. So I did a Google image search on these boards, and I've seen a few more that had these identical caps, the Nishikons, and had the same question of a polarized capacitor being used where a bipolar or non-polar should be. So anyway, maybe they were original. The soldering did look original. Right, so these have been replaced. Those colorful tropical fish ones have been swapped for these pink red ones. These are the non-polars here, and the blacks are the regular electrolytics. Okay, I have the amp up on its side now. I've loosened two flathead bolts, and this is flopped right out. So I'm just going to flop this down like that, and I'm changing the two yellow caps and the two blue ones. Same story as the others, just quick in and out. And that's it for the meter board. I may do some electronics testing with this up when it's up and running, but the meters did seem well calibrated and matched when I first tried it out. So I don't think I need to dig around too much in the meter calibration scenario. Okay, the last and most tedious thing I'm dealing with is having removed the multi-section capacitor can from the amp, which filters all the power supply sections other than the big blue ones. Now, I couldn't see this from where the capacitor was mounted in the hole sideways. I could not see it, but look at all the evidence of leakage. Look at the gunk that I just kind of flaked off, and that is clearly leaking around the edges there. I didn't see that when it was in there, and I actually thought it looked perfect. So once again, folks, no capacitors really have survived the trip. The last two I just took out of the meter boards. I might as well show you now too. These also had evidence of leaking gunk out the positive end. So very few capacitors overall have survived. Electrolytics always need to go. There's some folks, you know, there's in the guitar amp world, and I think in the McIntosh world as well, who speak against randomly changing electrolytics. They seem to insist that those silver capacitors live forever, but that is not the case. They've got to go. Okay, so this is the old multi-cap can that has 4 capacitors in it. Now, there's several methods that discuss taking out the innards of this and replacing these 4 capacitor sections are replaced by these capacitors here. So there's a talk of taking out the guts of this, stuffing these in this old can, and mounting it back the way it was. But I looked at a few videos about that, and the kind of way that I have to butcher up this aluminum housing to do that, I just think it's an absolute waste of time. So what I'm going to do, so this is where the capacitor mounted. There's a metal board that's shaped exactly like this. This is an isolated fiberglass version, and it's riveted there, and the capacitor has little locking tabs that go through these slots and hold it in place. Right, so I've stuck my Dremel in here and taken out 2 rivets there that I punch out. You can see the remains of 1 rivet on the right. This is the bracket that held the capacitor. So now I've just cut this little vintage style phenolic board with the holes in it. Of course, I could have done this with an insulating board that did not have holes, but they do actually line up. So that's just going to sit there and be bolted in place with the same holes. But on this side, you can see I have enough room to put an array of eyelets through which I could slip those capacitors. So let me bolt it in place, mock up the capacitors, put the turrets in and finish it up. So you can see what I'm doing there. I'm just pushing the leads of the capacitors through here, and they're each well clear of the surrounding metal panel. If I use 8 turrets here, I'm doing a real good easy service setup for the future. Right, so I have a selection of turrets in here. I'm going to use the biggest, fattest ones, which use a 1/8 of an inch hole, I think. I wonder if it's smaller. It's hollow up the middle. So the capacitor is going up through the bottom, up the middle, and I could poke in the circuit wire into the top neatly, or I could wrap it around a little bit before soldering. So I need 8 of these, and I'm going to drill. I mark the holes that I'm using with a Sharpie, and I'm drilling out those to the correct diameter. I think it's 1/8 of an inch, and I'll put those turrets in. Okay, so here's our finished little mini capacitor board, and these will be, outer ones will be the positives, right, and the inner ones are the negatives, individual negatives. So here we're gonna tie a common wire around the 4 inner ones, and that will be grounded, right? And then we have to figure out which section gets which capacitor and which group of wires goes to each capacitor section. Okay, so now I've come up with my board arrangement. This is the layout here. And in the 4 capacitor sections here, 2 of them have 3 wires each going on to each section. 3 wires going to one section, 3 wires going to another section. But then there's 2 capacitors, these 2 smaller ones below, where only 1 wire each is going to them. So I'm placing those at the bottom, so that when I install this whole thing, the messy wiring, which is the 3 wires here and 3 wires here, are right where I can deal with them. And the single wires, which are easy to deal with, are down on the bottom and out of the way. Alright, so we're in now. And I personally think that looks great. Kind of old school look, the turrets and the phenolic. And I can replace any one of these capacitors one at a time without moving anything else. Because once I heat a pair of turrets enough, that capacitor will just slip right out. Okay? Right, so reckoning the mess of wires here, it's pretty simple actually. Straight off of the rectifier here, we go through this wire here goes to one section. That's one of these bottom cans. Then you go through a resistor. Sorry, I'm pointing at the wrong thing. Go through a resistor, and we go through this other wire, the striped wire, another one of the bottom cans. Okay. Then we hit into the 90 volts section, which is this white wire. And I'm hooking these 2 blue ones onto there. Okay. The next section further down is a blue and white stripe here, and I'm hooking the same blue and white stripe wires to that section, and that's an 80 volt supply. Okay, so we have all accounted for. I really have to say I like how this looks. You know, it's not McIntosh original neatness. I could neaten up the little bends in the wires a bit much, but I think that's a better solution overall than the restuffing of the capacitor cans or trying to locate them anywhere else. Okay, we're back in action. Front panel's still off. Switch on. These are the new LEDs, nice and bright. Surely a lot brighter than the last incandescents. I only hope that this illumination on the other parts of the panel is what it should be. Okay, so moving over to this input board, I did take basic voltage measurements. And I did find odd voltages in this input board that made me change the transistors. I mentioned all that. Now, was that set of odd voltages a product of the old dead capacitors or the transistors themselves being off? Well, you know, chicken or the egg situation, right? But I did change them, and now every transistor that I measure is either dead on spec or a little bit higher, like 10%, maybe a little bit more than 10% higher. The thing is that after doing over the voltages for the preamp, I do find that the two high voltages, which are 80 volt and 90 volts, we're getting like 97 volts where it should be 90, 83 volts where it should be 80. So that's not too bad, but it does cause some little high voltages downstream. As I say, I kind of eyeball everything to be within, you know, around 10% within spec. Now, if I wanted to, I could adjust some of these resistors to bring down those voltages. But the truth is that that high voltage is not really likely any fault of the amp. It's that our modern wall voltages are usually a little higher than the old 117 or 115 that these were designed for. I'm going to poke around a bit more in the power section. Hopefully I don't see anything odd. Ooh, I'm a little worried right now, but it'll be okay. When I fired up, I only got left channel. Okay, playing around with this. And what I realized the first time I tested it was that this speaker jack, I was getting a problem with one of the channels. When I poke screwdriver in there and bridge over the right side speakers connections, they come to life. So I need to take down this speaker switch and give it a good cleaning, because I'm really 90% of the time I'm not getting the right channel when I make that click. Other than that, no hum, sounds fine. Haven't really hooked it up to a preamp yet. I was just kind of running my phone into it. But so that's not the full sound. I do have proper speakers here. I'm not in love with these tower speakers here that I have in my workshop. It's certainly good for testing, but again, to do over this speaker switch. Well, I have to remark that so far this might be the biggest component headache. This speaker switch is very much, sorry, I'm too zoomed in, hold on, very much sealed up. There's a tiny vents on this side, but really in this section here is where I need to get lube, but there's really not much space for me to leak some oil into there. I'll try, but so far this has been a little harder to service than any other individual thing. Wow, so I just took this apart by taking off 4 tabs around the edge. Took this apart, cleaned it. I put a little solder on the butt end of these terminals on the inside part. There's a flat edge, but I didn't film it. I was so stressed out because when I took this bottom wafer off, a bunch of little mechanical pieces inside, a spring and a little cast zinc piece and some nylon contacts came apart, and I spent at least a half hour trying to put it back together, and it's kind of impossible. So I'm not even going to show that on video. I didn't film it, but anyway, this is back together, and it will click. Don't take this apart, just replace it, okay? You're not going to get it back together, I swear. And right now I'm testing with my little meter to see if I get a nice continuity beep on these two here. These two are the offending ones, and they are working now. I am getting continuity here. So if I put this back together, expect that right speaker to be on when it's supposed to. Okay folks, I finished with that speaker jack issue. Now we have the faceplate back here, and I'm going to try something for the benefits of Mac users. We have one of the bubbles on the front. There's not too many bubbles on this. I'm worried about this glass chip there. That's worrying me more than anything else. Right, so there's a couple of bubbles, one here, and I could see clearly that it's just an issue of the paint peeling away from the glass on the inside. Now, surrounding what would be the headphone jack is quite a blob of glue there. That blob of glue, obviously shrinking over the years, has brought up a bubble. You can see it surrounding there, right? So what I'm going to try for your benefit is I'm going to razor blade away the paint here and just repaint it from the inside with a bit of black enamel paint. Okay, so I've taken a razor blade and I've just sliced and taken off where the glue was. And you can see I've made it worse. Isn't that brave of me? I'm going to back paint that and see what happens. Right, so just a touch of black enamel paint. I think I painted my front gate with this stuff. And I'm going to dab it where I've exposed the glass. And let's look at the front. That's it. Bubble is gone. Let me see, let me just dab that a little bit thicker. I don't know what type of paint was used on these. I usually use nitrocell. Ah, there you go. That bubble is gone. That bubble is just gone. Now these, what you see on these is sort of a mildew look. I don't know if I'm going to try to fix that because it's behind the knobs. But this grommet glue causing the bubble is now eradicated. Right, so that back painting got rid of that bubble so well. I feel a little more confident. I'm going to tackle this bubble, which is around the red indicator thing. Now the back here shows that the red indicator thing is probably just a strip of clear red held down by this scotch tape here. So I'm going to slice this all away and fix the bubble and then stick back the red. Here we go. I've just sliced away the red piece, which is just this. There you go. And there's two obvious bubbles right there. So I'm just going to flake the paint off. It's raised. And jam some black paint right against the glass after this is removed. Now if I keep picking away at this peeling paint, I'm sure it could only get worse and worse, right? Because, you know, paint is not going to stick to glass that much in the first place. So what I'm really doing is just peeling off the major loose bit, and then I'm smearing the paint in and let the new paint get sort of under the edges of you see, that could just keep peeling forever, right? Get the new paint under the edges of that peeling section so that the new paint is like a glue holding down the old, right? So I'm blobbing that there and I'm blobbing that there. That's it. And I will, oh, there's another little bit right on the edge of this indicator light. I can put a blob there and razor that section clean again in the morning. Is now kind of still showing, it's showing where the tape edge was, so I could tackle that, right? But you see the major bubbles before have disappeared. Now I'm going to stop here because I'm seeing a couple other spots that have like little glass chips and other little bubbles. I'm not going to dig around trying to fix the whole thing. Again, this crack here terrifies me. Okay, so I've done as much as I could and know how to do within the limitations of my knowledge and the kit provided. Overall, what's my review of that kit, the common refurbished kit for these? It needs more work on the information supplied with the transistors so that the change in pinouts from the old to the new should be clarified. Also, to the most difficult thing really physically was the multi-cap board, because building that from scratch, you know, is not part of the kit in any way really. And everything else was a straightforward swap compared to that. I'm going to put a tie wrap around this now that I'm looking at it. Okay, so I'm going to start reassembling the case. And you could see here the effect of the regular panel lighting. Looks pretty good. That red looks good. All of the lettering is very white, very very present. I'm just sitting here and I'm polishing the glass. Man, this came out so nice. I mean, the story of this, I didn't tell you the story of this, but basically this came up in a local estate sale and I kind of jumped on it. Very skeptically, like, wow, what am I buying here? Because locally, you know, I live here in the tropics and all equipment is generally very rusty, very abused and misused. I bought this not knowing if the auto formers were going to work properly, and I said if anything is wrong with this amp, I've wasted all of my money, because I wouldn't be in a position to fix, you know, replace those big transformers, or even the glass I'm told is hundreds of dollars. So anyway, I rolled the dice and it turned out real good. And these knobs just press in place. They're D-shaft, forgive all the paint on my fingers, they're D-shaft knobs. Pots, they don't have any set screws like most controls. There's a felt washer behind each shaft, and I guess it's to stop the knob from scratching on the glass when turned, but I also think it's to keep light out, making a sort of halo into the glass. I think so, I'm not sure. And I will say again, the lettering setup looks really great. White and crisp and sharp looking. But there's a big important issue that has cropped up in my mind that in my excitement and enthusiasm, I wasn't thinking about it before. How am I hooking this up to the rest of the system when this amp does not have a grounded power cable? It has a regular 2-prong plug, the original one, and it's not polarized. That is to say, the blades are the same size and could be plugged in either way. Okay, now lacking a ground prong, which you see on for the third hole here, lacking that means that this chassis is not actually grounded. Let me just further demonstrate what I'm talking about. The chassis of this amp is hooked up to this meter, and I'm checking the AC voltage between that chassis, which is switched on, right, and the actual ground of the power supply, which is this probe here. There is 39 volts AC, let's call it 40, between that floating ground and this actual electrical grid ground. Let's flip this around to see what happens. We just measured 40, let's turn it around. We've gone higher, right? So what happens when I hook this up to other equipment that is grounded, right? We're going to have a voltage difference between this chassis and the other piece of equipment. Okay, we've all heard about ground loops in the context of noise and background hum. I'm not really talking about it. I'm just talking about the power supply voltage and the safety of having two pieces of equipment next to each other, where there is a voltage difference between the two chassis of the different pieces of equipment. You touch one piece of equipment, you touch the next one, and there's this voltage flowing through one of your limbs and the other limb. Okay, so having demonstrated that, I am not leaving this with the original 2-prong plug. I'm sorry. I am from the guitar amp world, and all old guitar amps have been converted from the 2-prong system to 3-prong plugs. So I've picked out a cable, and I'm going to take this out and replace this cable with the 3-wire version. So I picked out a nice 5.5 feet power cord over here, and I'm just going to cut off this end. I wanted one that's thin enough to pass through the original hole here, which I think should work. Of the 3 new wires coming in, I have to put 2 replacing these 2 existing ones here. All right, one goes kind of directly to the fuse and onto the power switch. Basically, I'm putting the hot wire on the fuse side, and I'm putting the neutral or cold wire on the other one going to the thermistors. Now the third wire now is the ground one, attached to this point here is an unused ground terminal right here that is grounded to the chassis. That loop right there. Okay, so I think I will attach my power ground to this, right? Okay, you can see the old wire on the left, the new wire on the right. They look real similar. The one on the right, the old new one, looks a little bit thinner, but they kind of both look like they fall into the same category, which I think is 18 gauge, right? I don't know that that one on the left is a 16. Anyway, so this is stripped back, and the green one with the yellow stripe is the ground. The blue one is the neutral. Light brown is the hot, right? And those are coming in here. I'm going to try and reuse this connector which goes through the chassis. This is I always call these Heikos. That's the brand on them. Or any other similar one that fits through the same hole. Here's the hole. So again, I'm coming back to these connections here. And that ground there. Right, so I'm actually quite done. Here we have this very light brown wire going to the top here. That moves on to the fuse, which according to the schematic goes on to the power switch, which is on the front here. And the blue one, which is the cold connection here, goes on to this, just to meet this terminal here, and it goes on to a black wire that goes, actually I'm not sure where it goes, I haven't traced it. I don't know where it's going, but on the schematic it goes to two parts in series with each other called S302 and S303, and I think those are thermal fuses. I'm tackling the tropical fish capacitors up in the corner here. Some were included in the kit to replace these, and I didn't know if to bother, but geez, as I put my hands on these things, right, they just fall apart. Look at this, you know. So geez. So what I bought here, finally, again, one of these kits, I guess this is a full kit. I've gotten a strip of blue that is meant to be placed here. I guess that's this strip has to be replaced. Don't know much about it. This actually looks larger, but I'll go with it. Okay. And then we have two LED bulbs that look similar in structure, but different in color. These have a white ring, and these have a yellow ring. And I don't even know which one goes where. But right now I only really need to do the meters. I'm kind of happy with the panels as they are now. They're quite bright and look nice. So let's brighten those up. As I say, I'm pretty happy with these ones here. These are the white ones, not the yellow, white, yellow. Now let's have a closer look at these bulbs that I bought. These are the original lamps here. And we can see some people have made issue that the height of the lamp is necessary. You can't put in a shorter bulb, which may not reach to the right spot on the prism of plexiglass here, but these seem to be the right height, and they have these ridges in them which seem to be there to distribute the light. So much of a difference. But again, listen, I don't know anything about these amps. This is the first McIntosh I've ever dealt with, and I didn't know what it's supposed to look like. Some new McIntoshes are very vivid blue, and these older ones tend to be sort of greeny and not really uniform from top to bottom. And that's what we're stuck with, I guess. Okay, well, maybe now we're getting somewhere. In each of these plexiglass prisms, there were two flathead screws holding down each one. I've removed those, removed the plexiglass prisms. And in it is this folded blue gel, which is a term for color-tinted plastic. But we could see here that in the area that the light was passing through, it did turn entirely green, right? This upper blue section here has turned mossy green in the area that was in contact with the tip of these prisms. So this new gel here is meant to replace them, and I have to fold it and put them back in just where I took out this one on the left. Alright, so I've just removed the protective coating and we see the difference in colors here. Look at that. So our meter really might be blue and less green when I put this one on the left in. I just have to fold it into an L cross section and stick it in place. Right, so out with the old and in with the new. Really clean those plexi prisms as best as I could. You can see here lots more evidence of other little spots I had to fix. I had to do quite a lot of repair work around the red meter light. So what I'm going to do, clean the glass as best as I could. And here, so there's no fingerprints showing through later. Man, this thing was so crusty looking when I first got it. And now it's just a lovely piece of glass with minimum bubbling. There's a bit of a crack and splintering here. I can hardly see it, but like it looks like something hit here and kind of splintered the glass. I'm amazed it didn't break. Anyway, let me put on the last of the knobs, which just press on. I think I'm going to give these knobs a little bit more of a soaking because there's still some dirt in the grooves. Alright, and let's just switch on. Let's see how it looks with the new gel. Ooh, that looks very nice. That looks beautiful. Our lettering is nice and bright and white. It's not yellowy or greeny or whatever people say. And these meters are blue, blue, blue. There's no yellow or green coming through here. That's really fresh. Wow. And note about this. This area had bubbled and deteriorated. So I had to come from behind and build back the black rectangle of paint and through which the light shines, and I actually made it a little bigger than it was before. That looks really nice, doesn't it? Yeah, man. I modified my very old speaker load this morning. It's a bank of 4 ohm 25 watt resistors. It's now set up to have 8 ohms 200 watts, right? And we've got this old phone here feeding out a 1K signal. Now this going straight into there does not give enough voltage for full power output, so I'm actually passing it through this DJ preamp here. We have some signal coming in. We're looking, oh, just at the square top there. Oh man, let me tell you, my resistors are hot. So I don't want to keep running this too long. Yeah, you see, set a flat now, just there. It starts to flatten. Just there. And that's about 30 volts RMS. So let's stop there. Don't want to burn up my resistors before I get to the other channel. They are really hot in there. Right, so having gotten the clean peak of 30 volts RMS, we square that number, we get 900. Divide by 8, that's the impedance, well, the resistance of the load, and we get 112.5. So it's 112.5 watts clean, right, before that square wave clips in. So that's just a little over the rated the rated wattage, and that's great for a watt 50-year-old amp. Let's move on to the next channel. Okay, now the exact same thing into the left hand channel. Again, I'm just turning up this big volume knob down here. This is on full signal, which does produce a clean wave. This is on full volume, and we go up, up, up. This needle goes all the way to the right, and oh, we squared off right there. So again, let's look to see if we can get that 30. Right now it's a little dirty at 31. Bring it down. If I could just have a clean wave at 30, it means our channels are well matched. I would say yes. we got a clean wave at a little over 30, which is about the same as before. This volume knob is actually a stepped knob. It's not a smooth, so what you see me doing here, in between this slightly flattened section and this very curvy section, is one of the clicks on the knob. So I'm sort of riding in between the two. But I'm definitely getting totally clean at 28. And I am still clean at 30. In fact, about 30 and a half is where it probably starts to square off the top there. So I would safely say that we're hitting 30 here, and we have the same voltage rating, wattage result as the previous right channel. So both channels hitting this figure. Brilliant, right? That's more than I could ever expect or ask for. Great, so I think that concludes my refurbishment video. As you can see, this was a learning process for me, and I think I've learned quite enough that I could tackle another one of these easier. Right, so again, thank you viewers. Until the next project.